Assalamualaikum and hi, my name is Nuriza Atira binti Muhammad bin Hisham. So now I will present about the introduction of our mini project which the determination of SPF value of sunscreen. Do you know about SPF? SPF is short for sun protection factor. Each sunscreen product has a sun protection factor that tells you how much protection you will get from UVB rays with a number denoting of the level of protection. A product with a higher SPF will offer greater protection, while a lower number will offer lesser protection. Higher SPF content like SPF 50 or SPF 60 is ideal for outdoor use, whereas lower levels like SPF 35 or 30 is suitable for indoor use. You can find out the level of SPF in sunscreen by reading the packaging. Why we need to know about SPF value of sunscreen? Skin is vulnerable to photo damage due to exposure to sun radiation as well as other environmental factors because it is the longest and most exposed region of the body. Next, we need to know what the effect of UV radiation of our skin. UV radiation is mutagenic. It accelerates the aging process of the skin, depresses the skin immune system, and causes photodermatosis. Long-term UV radiation exposures causes oxidative damage by producing reactive oxygen species called ROS. Skin cancer is one of the many skin illnesses that ROS causes to grow. So in this project, we run a program for the user find the best SPF value of sunscreen for their skin.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. I'm Putri Karunisha binti Arifin. My ID matric number is TJ22024. So I'm going to present about the problem statement in our mini project, which is about determination of SPF value. So in our project, the variables that we use for this project are correction factor, which is CF, spectrum effect erythema, EE, and absorbent, which is ABS, where the CF and EE times I are constant. The quantities to be determined are the SPF value in order to apply in our product. Furthermore, we will be able to identify the best vegetable that can be used in making SPF product in pharmaceutical manufacture. Hence, in this program, we also can compare the amount of the SPF value for each vegetable by plotting the bar graph. We also are able to calculate the time SPF protection for our skin by using the GUI program in this mini project. Okay, next I will present about the mathematical equation, which is in this mini project we are using two equations. The first one is Mentor equation, and the second one is about how to calculate the time SPF protection. So the first equation is SPF equals to CF times summation from 290 until 320 times with EE times with I and times with the ABS. So when we calculate this, we will get the SPF value. So for the second equation that we use is time SPF protection. So when we want to calculate the time SPF protection, we need to multiply time skin burn when exposed to UV light with the SPF and SPF value.
Hello everyone, my name is Konia Nasunai Anak Namarijau. My matter ID is TJ22070. Today, I will present about the flowchart first. In the flowchart 1, we want to determine the SPF value. So, in an oval shape, we put start to show that it was the beginning of the section. Then, in the rectangle, we create the table of the sample data absorbance to determine the SPF value. In the parallelogram, you can enter the absorbance value for each lambda. Then, you can calculate the SPF value by using the Mentor equation. Next, the output will display, and to end the section, we put an oval shape with top. Next is flowchart 2. In flowchart 2, we want to determine the SPF value by using the SPF given in the vegetable. First, we started by determining the SPF value by using various of properties such as green root, drumstick, sweet potato, pumpkin, bitter gourd, potato, brinjal, and capsicum. We put the SPF value of vegetable as output. So, for the green root, the output is 17.93, the output for drumstick is 17.49, the output for the sweet potato is 12.23, output for pumpkin is 11.73, output for bitter gourd is 4.36, output for brinjal is 4.31, output for capsicum is 2.46. Then the output is sent to the result to the screen so the output can be displayed. Then we can create the bar graph of SPF value for all different vegetables by using the data given. Then we end the section for the flowchart too. Then I will explain about the flowchart on how to create GUI for the study case 3. First, we create a blank GUI. Then we create the edit text box for all input and create the static text box for all input and output. Next, we label all the static box. After that, we create a push button for close, multiply, and reset. Then, we change the tag name for each box, the type of the comment to each input under the cell compound. Next, we change the string type to number for input box and add the formula under callback compound for the respective button for calculation. Last, we save and run the file. This is our last flowchart, which is flowchart 4. In this flowchart, we want to determine the SPF sunscreen that's suitable for different skin. We proceed the flowchart by using start over shape. Then, we determine the SPF sunscreen that's suitable for different skin. There were many types of skin, which is very fair skin, light skin, medium skin, and dark skin. Next, the output is to show the SPF that you need according to your skin. The output for very fair skin is in 1 hour, you need SPF 15. 2 to 3 hours, you need to use SPF 30. 4 to 5 hours, you need to use SPF 50. Next, for fair skin is, its output is for 1 hour, you need to use SPF 15. For 2 to 3 hours, you need to use SPF 30. For 4 to 5 hours, you need to use SPF 50. For the light skin, its output is for 1 hour is SPF 8. 2 to 3 hours is SPF 50. 4 to 5 hours is SPF 30. For the medium skin, its output is 1 hour. For 1 hour is SPF 4. 2 to 3 hours for SPF 8. 4 to 5 hours SPF 15. Then, for the dark skin, the output is for 1 to 3 hours is SPF 4. 4 to 5 hours is SPF 8. That's all.
My name is Nurzawana binti Kamar Nizari. For the case study, in the real life, to conduct an experiment to determine the SPF value from the extracted vegetable, we use the Manso equation. Next, in this topic, also we calculate the time for SPF to protect our skin. Also, we can determine which SPF values that we can use based on our skin color, because everyone got different amount of melanin in our skin, so that's why our skin color is different. In the Manso equation, we build tables and user-defined function in the Matlab to calculate the SPF values. First, we provide the absorbance values for all the vegetable, which is the green root, drumstick, sweet potato, pumpkin, bitter gourd, potato, and brinjal and capsicum that we provide from the experiment result. Now for the table, we insert all the result that we obtained before, so that when we run it, we can obtain all the list of the absorbent values for each vegetable. Okay, next we use all the information from the table previously to we insert it in the user defined function, and then the Matlab will calculate the SPF values for the vegetable we choose. In the same master equation, we also build the switch case and bar graph. For the switch case, we already put the SPF values for each vegetable. The purpose of this switch case is to make it easy for us to see the final value of SPF by clicking one of the options. Okay, for the bar graph, we use it to do a comparison SPF value for all the type of the vegetable. Okay, from the result in the bar graph, we can conclude that green root has the highest SPF values compared to the other vegetable. Okay, while the capsicum has the lowest SPF values. Okay, so we can say that green root is much better compared to the other because it has the highest values of SPF, which is good for our skin.
My name is Nur Atika Syafiqah binti Abdul Hamid, and I'm going to present about our third study case for our mini project, which is time SPF protection. So for the equation for time SPF protection, the equation involves time skin burn when exposed times SPF value to UV without SPF. In this equation, we decide to create a GUI graphical user interface in Matlab to calculate time of SPF protection by multiplying two inputs, which is time skin burn when exposed to UV without SPF and the SPF value. In this case, we will get to know the value of time SPF protection by using this GUI that we make. The the user will be able to obtain the accurate value to identify the best SPF value for their skin. So we have provided a video of we running the program. So we have run the program in the Matlab and we have input 120 for the sun skin burn when exposed to UV without SPF times 30, which is SPF value, and we get 3600, which is the time for SPF protection. That's all for the GUI, which is graphical user interface. Lastly, for our fourth study case for our mini project, we make switch case menu to make it easy for us to see the type of skin that people have and the SPF which is suitable for their skin by clicking one of the options below. So I have provided a video recording for the Matlab run for this coding. So like in the video provided, I have run the switch menu case for the fourth case study and I have clicked the medium skin and the final result shown is for the medium skin, which is the answer will come out when we choose the fourth option. That's all.
From the study of our project, the study offered sufficient evidence to establish that many vegetables have sun protection properties that can protect the skin from detrimental effects of various psychochemical variables. By using Matlab, we can determine the best vegetables that have the highest value as SPF that we can use in manufacturing the SPF product. For the graph, it shows the comparison for all types of vegetable to compare which one is the better vegetables in SPF product production. We're coding for equation 2 to know the time of SPF protection function. Thank you.